begin with, let me introduce myself as a person who has been doing aquaculture for a long time, and nearly after my first 20-25 years of aquaculture, we reached a point where we couldn't go any further, and then we had to, I was just a biologist that time, and then we had to go towards engineering and combine this whole engineering into biology to grow further, because we reached a point where we just could not grow. And that's how Ecosecure Systems was born, and then we started basically concentrating on zero exchange. So technologies where we do not use water, or use the same water, or recycle the same water in the same system. So recirculating systems is one of the most oldest ways of recycling water. Now there are new technology also, like bioblock and aquaponics, and so many other new emerging technologies. But this happens to be one of the oldest kind of technology. And let's speak about this particular stuff right now. So why do we need to change water? I mean, why should we use the same water? Because on aquaculture, when the water becomes dirty, all we do is we just change the water. And this used to work for a very long time. But then what happened was that with the growing pressure on water and land and so many other things, our natural resources are not so pure anymore. And that's why we had to resort to this. So let's look at the reasons why we need to use the same water again and again. If you look at the sea or even the rivers, now this clean the Ganga and everything. So all natural waters are getting polluted more and more year by year. If you see the higher and higher toxic levels in the water, so it's instead of changing water, I would rather not change the water. The water becomes so dirty in the nature or the raw water. Also, the viral and bacterial loads have gone up because of very high organic loads in the water and high nitrogen levels in the water. So, the bacterial and viral loads have increased not only in the sea but everywhere, even our fresh waters everywhere. And so, with all these things, also we started using antibiotics finally. So much bacteria and so much virus. We finally used to keep on treating our fish and shrimp with more and more antibiotics, and it became very, very tough, because now finally when we export our shrimp, they check for antibiotics and they say, no, you cannot use antibiotics. So very tough to produce without antibiotics. So what do? Again, we were not allowed to release our water into the rivers or sea, because it would pollute. So the pollution control laws will become stricter and stricter. We have to treat our water before that. So producing fish or shrimp was becoming tougher and tougher, without using any other technology but just change water. So we thought that no, there is no future to this way of managing our water. I mean, we cannot depend on just changing our water, and we cannot do that for in future. So that's not the future. No, definitely it's not. So what do? So all over the world, if you see, look at RAS, becoming more and more popular, and especially in the Western world, where probably because they have very cold winters, for the temperature reasons, they adopted this much before us. But here temperatures much ambient, but for some other reasons we have to adopt them now, because the source of water itself is a problem. But having said that, we have a lot of cold winters in the northern parts of our country, where also this may be one useful technology. Then for culture stock, now we have these hybrids and so many new breeds of fish, which are actually not from nature. So just like you have breed dogs which need more care, just like that, all these breed fish and shrimp also need more care. So they are susceptible to infections, is that. So it's better to protect them using RAS. Also, with the new SPF stocks, which are very clean, which have no pathogens at all, to protect and keep their SPF status, we need to protect them from viruses coming from outside water. So hence, we need to use these kind of systems to protect our stocks. So if you look at water exchange, how risky it is, because you change water and this is rising all the time. I mean, the viruses, pathogens, the amount of pesticides, fertilizers, toxic chemicals in the waters are rising all the time. And it's troubling our fish and troubling our shrimp a lot these days, because we have seen that immediately after rains, when all these dry rivers, suddenly the water comes down into the sea, all hatcheries marine hatcheries will have a huge problem. You know why? Because in agriculture now they spray so many pesticides and fertilizers. All this will wash down and come into the sea. And after the first stage especially, there will be a huge problem with all these marine fish breeding and shrimp breeding. And so all these problems are coming up and rising every year. And it's also becoming more and more expensive, because we use chlorine to kill everything first. And then we use a lot of power to dechlorinate it. And then change the water every day. And almost 50% of the manpower is only doing that in our aquaculture. They're just changing water. So which is a huge waste of manpower and power and chemicals. Also to treat our water, we need these big reservoirs and treat the water with chlorine and dechlorinate it. So we need this raw water treatment facilities. We need also effluent treatment facilities, which consume land and also power and chemicals and manpower. So all these things are becoming more and more expensive to build into our systems and change water every day. So changing water is becoming risky and expensive. So what is the new strategy for future growth? It's only recirculation, because it's cheaper and safer option. So if you just say recirculating aquaculture systems, what is it all about? And then people say, oh, it's like a magical equipment available somewhere in Europe or US, and we don't know what it does and how it does. So let me just clear your mind of it. It's very simple. It's not very difficult. It's not very complicated. What we do is we just split all the dirt. Suppose we feed our fish. Then what happens to the feed? The fish eat the feed and they excrete a lot of dirt and a lot of pollutants in the water. So all these excreted matter has to be clean from the water at the same speed as you are feeding the fish. So it's per minute, per hour. It works like that. So now we have split all these into various sizes. First of all, the what is known as suspended solids in the water, which you can actually see some of them. So the larger suspended solids, more than 100 micron, can be settled down. So there are traditional methods of separating them. You might have seen in your home aquariums, you do a bottom siphon and clean all these settled items. Or now even in big farms, they do what is called as take a pump in a boat and then they siphon all the settled dirt at the bottom. So this bottom siphon, okay, that's existing technology. But what's new? What is in RAS? RAS has a much better technology called settlers. So the water first goes into settlers, and this larger sediments are removed. Then after this is done, then we go down to 20 to 100 micron size of particles, where traditionally sand filters are being used. Swimming pool filters, sand filters, even for water treatment are being used, but they are for clean water. Now, if you try to use a sand filter on aquaculture water, which has very high organic load, after a while, with the high organic load, all the sand particles start sticking to each other with bacterial growth, and the whole sand filter becomes about 5-6 bricks, and the water just channels through that. So it becomes totally useless. I mean, So you can't use a sand filter to clean a very high organic load water. Only in a swimming pool where chlorinated water is there, very clean water originally, you can use sand filters very well, but not here. So what we use in RAS is drum filters, and now even better bead filters. So these are the technologies which are used to remove solids of these sizes, in between 100 and 20 microns. Now if you go down below this, then what happens is even these are unable to, these devices are unable to remove these particles. So what we do is, normally in our drip irrigation systems, in our home whatever AquaGuard or whatever you have drinking water systems, we use cartridge filters to remove this kind of solids, 1 to 20 micron. But on an industrial scale, you can't use cartridge filters, because cartridge filters they don't give a constant output. You see, they through time they will get clogged, and then the flow rate will drop. Then you have to remove them out. Then you have to physically clean them, again put them back. And with this cleaning itself, they will deteriorate, and finally larger particles start passing through them. So they don't give you a constant kind of output. Sometimes you will find a lot of 20 micron or 5 micron pieces escaping even through cartridge filters after some time. So you have to keep changing them. But what happens in the new technology? New technology, we have things like foam fractionators, or what is called as protein skimmers in aquaculture. So these, what they do is they remove solids between 1 to 20 micron with the use of bubbles. So what a foam fractionator does is it produces small bubbles, and a bubble has static, it has surface static. So what happens is very fine particles stick on each bubble, and all these bubbles will come up as foam, and this foam will actually remove all your fine dirt, which is around 1 to 20 microns. Now coming down to even smaller stuff, that actually dissolves in the water. You can't actually catch it and pull it out. So these are all things like gases, ammonia, CO2. These are also pollutants in the water. As your aquaculture environment becomes older and older, it accumulates a lot of ammonia and carbon dioxide. Both are very toxic to fish, and so you need to remove them. So in natural systems, what you do is we just grow algae, and algae take care of all this. They remove the ammonia, they remove the CO2, and you are very happy. I mean, people are basically, maybe large biofilters, very large biofilters, where they use these shells and all those things, but they too are now consuming so much space and so much labor that it's becoming uneconomical to use them. And algae has a limit. They are limited by how much sunlight falls on your pond. So if you want to go beyond that much sunlight is not available. Then you have to increase the pond. But in the same pond, only limited amount of sunlight falls. So only that much algae can be active. Also, there is no sunlight at night. So there is fluctuation, day, night fluctuation. This will stress your animals. What you need is a constant. You need a constant. Algae don't give you a constant. So we need a new technology. So how do we control all this? So we use biofiltration. Now biofiltration is nothing but use of two kinds of bacteria. One is nitrobacter and one is nitrosomonas. So these bacteria will oxidize ammonia to nitrite and then nitrite to nitrate, and that's how they will remove the ammonia, and then you can with the bubbling and aeration you can remove most of the CO2 in our weather. I mean, in cold weathers the CO2 is a big problem, but in warm weathers it's not such a big problem. Bacterial loads also keep developing in our systems. Even they have to be dealt with. And UV is a very good device to reduce bacterial loads. But even UV is just like our cartridge filter. Through time, the tube will become older and older, it becomes less efficient. So what we need is a constant efficiency. So there, ozone comes in. Ozone is a wonderful gas which is about 27 times more powerful than chlorine. But it just, afterwards there is no pollution. It just becomes oxygen. So it's such a very good gas to use for killing all the bacterial loads and keeping them under control. So this is how what the whole components of RAS is all about. And a whole system, an RAS system, consists of different unit processes which are connected to each other. The water just flows from 1, 2, 3, 4, 5, 6 and comes back to the main culture tank. So that's what RAS is all about. Nothing so complicated. So to start with, I'll just show you one simple RAS. So this is one of the simplest RAS that you can have. This is just one couple of biofilters. These are bubble washed biofilters. So these are the new generation biofilters which do not need water to backwash, because we are trying to save water here. So we can't use clean water to clean our biofilter and make it dirty again. So these do not need clean water to wash them. What they do is they have floating media inside, and they can be washed with air. So only the water inside the biofilter comes out as sludge after scrubbing with bubbles. So it's bubble washed or air washed. The media gets washed with air. So you don't. It conserves a lot of water for cleaning also. And these filters, you can see all these valves can be operated only with valves. So you don't have to get your hand dirty or anything. It's just few valves. You open them, close them, and the backwash is over. 3 to 5 minutes. So these valves can also be automated. So you, like a washing machine, you can have a washing cycle on a timer, and you can just keep backwashing once a day, twice a day, or once a week, or whenever you want, and as you wish. So this is one of the most simple new generation systems, which now we are operating about 50-60 systems like this in Chennai on koi pools. So they are very large koi pools, some as big as this room, and we put filtration systems on them. And the water remains so clean that you can't see the water. You can only see the fish. Even in outdoor, inside under sunlight. Normally, if you have seen a koi pond or any pond, you see completely green. You can't see the fish unless you throw feed and then you see the fish. But here it remains very, very crystal clear with filtration. So this is one more now in freshwater side. Coming to marine side, marine systems. This is one system which we installed on shrimp, marine shrimp hatchery. So on the maturation where the brood stock is kept. So this system has so many components, like what I just said. All the components it has. What I just said. The biofilters, the protein skimmers, the ozonizers, settlers, ozone generators, everything. So these are the complete systems for marine seawater. And this is the maturation tank which that system is operating on. So these are two water settler is, because this is the main settler where the water comes in first, and from there the bottom water, it swirls inside. So all the heavy material goes in the bottom. This bottom material just comes into this accumulator, and the top water, which is much cleaner, goes into the sump. So this is what we see. These are the fecal strands of the maturation animal. So they completely remove it and keep it separately in an accumulator, which can be with one wall. This one, all the dirt is removed. So this is the way settlers work. Then biofilters basically work.
Are there any valves there?
Yeah?
Are there any valves there?
There are valves, yes. Here. There are valves for all these 3 devices. In fact, there is a submersible pump in the sump, which sends water to the other system. So by gravity, through the culture water, it comes into the settler, and then it gets pumped out into the other filtration units from here. So this is the first step actually to remove larger particles.
So the metabolite settling on its own, that settling tank?
Yes. By using
It settles on its own.
yes, by using centrifugal force, because the water goes in tangentially. See, this is the inlet for that.
Yeah, so there will be current.
Yes, there will be a teacup effect. Like there is a small dimple in the middle. So and then all the settled matter will come down and flow into this accumulator. So that's how it is designed. It is completely engineered, designed this one.
Between the settler and the sump,
Yeah.
what kind of valves work?
There is no valve. There is only a top water just flowing on top. It's skimming.
That's it.
Okay. Skimming into the sump. So these are basically again the same bubble wash biofilters. These can remove up to 10 to 1000 micron suspended solids, and these are combination of your drum filter and biofilter, 2 in 1. So you will only need one device to do 2 device work, and this has no moving parts like the drum filter. Drum filter has moving parts, so the bearings will go in time, and some parts will, because it's moving, may wear out. So here nothing wears out. These work these are now in some places around 7 years old, and they still work. So there is no maintenance free, and they have very high surface area. Each one these has 100 square meters of surface area. And your biofiltration capacity is measured in terms of surface area. So because that's where the bacteria live on the surface, and so the larger the surface area, the more bacteria you have, and so the more work it do. So these are what are biofilters. These are foam fractionator and with the ozone generator. So we first ozonize the water and then foam fractionate it while deozonizing it at the same time. So this is also another 2-in-1 device what we designed. So this removes very fine particles. Actually, this was a video where you could see the foam coming out here, but I can't run the video now because some system issue. Anyway, so this is the foam coming out. As you see, it continuously removes the foam out and it goes into the drain. So with the foam, all your fine particles are going out. Okay, so okay, now we know what it is. Then where do we apply these systems? So it can be applied in most places, wherever you need very careful and very expensive actually fish there. You should be using it. So first of all, you use in maturation in nurseries and grow out and domestication. Even domestication programs can use this with the SPF material. In maturation, you can see that it uses less than 10% water per day, while normal maturation uses around 200%. So it's 20 times more efficient as far as water usage is concerned. And it maintains constant ammonia, which is almost zero. And any temperature you want, you can set the system to temperatures. These systems we can use chillers as well as heaters. So we can set the temperature of the system. It remains constant throughout. So temperature is constant. Salinity, of course, because we don't change water. Even if it rains outside or heavy monsoon or whatever, salinity does not change because it's inside. Then we have for the brood stock, they become productive for a longer time, and because of constant conditions, they don't get stressed and then they don't fall sick. So they're very happy and they keep producing more and more eggs. It's very biosecure because you don't change water, and because you don't change more water, you don't need such a big effluent treatment. And because you have less water, again you need less people, you need less chemicals, less power also. So all these things are there in a maturation system. And this is a nursery. In the nursery also the same devices are being used, and you can have a closed nursery like this which is biosecure and does not harm. Because nursery systems we recommend now for shrimp farms, they should be near farming areas, but they should not pass on the disease to the farms, and the farm should not pass on the disease to the nursery. So it requires to be biosecure. So all these advantages are there: biosecurity, economy, predictability, because the animal does not die soon, or you don't have disease and things like that. So more predictable. You don't need to use antibiotics. In fact, you cannot use antibiotics in RAS because it will trouble the bacteria which are in your biofilters. And that's why, because of all of these things, it's very eco-friendly. So, regarding biosecurity, again, I want to stress that biosecurity does not mean that you do not catch a disease from outside. It also means that you do not pass on the disease to the environment. So, both ways, if you see these two arrows, both ways you cut this whole cycle. So, this is what a biosecure facility is. Especially, I am showing this because many people just think that it's, you should not get disease from outside, but it's both ways. And, so, entry and exit of pathogens is restricted with very low water exchange. If you see economy, this has been worked out long time back in a hatchery environment for per million shrimp larvae. So, if you were to use water exchange, you see the blue columns where the cost of each power, chemical, labor, and tank volume, the volume of water itself that was used. So, in every subject, the usage of power, chemical, labor, and the volume of water, if you use recirculation, you are using a lot less, especially chemicals. And that makes it very, very eco-friendly because you use very less chemicals in RAS. So, because of low risk, you get very high predictability. And predictability is one thing which is missing in fish and shrimp culture. Nobody can plan their next 5 years production, or if they are doing monthly or quarterly, or they cannot plan because they don't know exactly how much they are going to get. But with RAS, things definitely become more predictable. So predictability means there's less risk because the high risk you cannot predict anything. So why is it predictable? It's predictable because we have constant parameters. All parameters are same. There is no algal systems where pH goes up and down, ammonia goes up and down. Everything just varies every day. So there's no stress to the animal, and hence animals are more healthier and fall sick much lesser. And of course we protect them with the biosecurity and we isolate them from weather. See, weather is again a huge factor to stress your animal. And is also something where you can do things which you cannot do in say off season. In winter I can't do something, but with RAS, yes, you can do it in winter. Or I can't do it in North India because it's very cold there. No, you can do it there if you use this. So all these things are possible, and this weather related issues are much less can be controlled in RAS. Of course, water quality fluctuations due to weather can be controlled, because if there is heavy rainfall and everything becomes turbid in the river, but your water is your water inside, there is no turbidity. Or suddenly the sea salinity goes down, and then what do? You can't breed your shrimp or fish. Then what do you do? So it does not go down because you are not changing water. So all these weather related issues are not there. Antibiotics, of course, to control the levels of, we use only ozone here, we don't use antibiotics. And that's why with the higher biosecurity and reduced levels of suspended solids, we have less stress and to the animal, constant dissolved oxygen, pH, alkalinity, temperature, everything can be maintained constant. And we use probiotics in RAS, we don't use antibiotics. And ozone is continuously keeping all the bacterial loads under control. So this is how we maintain antibiotic-free status in our RAs. Eco-friendly because hazardous chemicals not being used, and we don't throw all dirty water into the rivers and seas and everywhere. We do not consume so much power because we use much less water. The main power consumption is to pump so much water inside and pump so much water outside. So all this is avoided. And because of high densities, we use a very small piece of land. And land itself is a limited commodity, and we use much less land to produce much more fish or shrimp. Also, we don't release pathogens to the environment. And that's how these kind of systems are certainly more eco-friendly. And that's the end of this talk. Please, you are welcome to ask anything, any questions.
This ozone, do you replenish it regularly? What is the operational cost?
Ozone operational cost is only power,
Okay.
because we have two devices in this. There is an oxygen generator which separates nitrogen from the air. Actually it's an air separator. It's an oxygen separator, and it just takes atmospheric air and splits it into two parts. One is oxygen, one is nitrogen. So this oxygen is then supplied to an ozone generator, which takes O2, and under a certain electrical device passes through, and the O2 becomes O3. And it's just air finally. We take something from the air, and then so everything goes back into the air afterwards. So we are not doing anything, we are just consuming power. These machines need small maintenance, but there is no continuous consumption of any material or anything.
I just want to go back to the scheme of the whole thing, where you have put them all together in one location. Yeah, that just good.
Yeah, this one.
This
Yeah.
one.
Yeah.
So, is there any possibility for gravity here?
Yes, we use only single pumping to avoid to use less power. We use gravity very efficiently so that the water flows through all these devices
Without any
with
power?
a single pump. All our systems have only one pump.
So you require an overhead tank for this?
No,
You don't.
no. There is no storage. The storage is your culture tank itself.
So that is located at a higher level, is it?
Which one? No,
The
some devices
culture
are
tank.
located at lower level, like the settlers.
No, the culture tank is located at a higher level.
The settlers are the lowest situated.
Settlers are the
Yes.
lowest.
Then bead filters are under pressure, so there is no gravity, there is pressure. But from there, then again the other devices are little higher, and then the water comes cascading down through all these devices into the tank. Yes, so this is how it moves. Gravity, of course, has to be studied in this and used to our advantage, so that we don't have to repump the water.
Have you ever worked out a model where solar energy is also integrated into this?
Certainly, most of our pumps are very small, just half HP or 1 HP, and I don't think that's a big problem for solar energy. Certainly can be, gentlemen here can throw more light on that. But yeah.
But that has not yet been integrated anywhere in the country.
It is very easily possible.
But it has not been done.
No.
Not done.
Not done.
There is a solar energy.
This boy, Vishwanath, has done something here. He uses only solar.
Only solar in our aquaculture system.
Yeah.
When it is aquaculture, it is like 24 hours solar. It is not possible in our agriculture. And at the same time, that solar power, we want only 600 watts motor, we can use it. But I will install in 2.4 kV power of the solar system. That another 1800 watts we can save our inverter system. That means that I can use a 3 kV inverter and 188 batteries also. That system is 24 hours non-stop, they were going on.
So the sediments that are settled in the settler tank,
Yeah.
what is the treatment for that? What
Actually, we do land filling or use it as fertilizer for different plants.
is it okay to be used as a fertilizer?
It's an excellent fertilizer because for our koi ponds, which use fresh water, the backwash water is the most desired by the gardener. He says, no, give me here, give me there. I want these plants to grow. So he's really very happy with that.
So it has a market.
Oh yes.
It has a market.
Yes, certainly.